What is up, YouTube? Welcome back to another episode on Code with Annie. And in this particular episode, we're going to take a look at the logic for insertion sort written in Java. And just a quick recap, insertion sort is nothing but the sorting technique in which we logically divide the array into sorted and unsorted halves, and we pick elements from the unsorted half, and we compare each element with all the elements on the sorted half of the array. And we do this in one pass, and by the time we reach the last element of the array, we would have already have a completely sorted array on the left side of the portion. Other than the last element, everything would be in the correct sorted position, and the last position will be slotted in accordingly based on the comparison. So if we try to implement this logic in Java, this is how the code will look like. And let me walk you through this particular code and do a dry run to show you how it executes. All right, so let's say you have an array of 5 elements sorted in descending order. So it's completely descending 190, 70, 60 and 30. And I expect the end output to be 30, 60, 70, 90 and 100, which is the ascending sort. Now, in order to do this, I have a function called insertion sort. Insertion sort operates from the position 1 because I take up the position of element 90 and I'll pass the entire array to it. And then what I do is in current position is equal to from position. So why I do this assignment is because I want to keep track of the original position that I passed to this function, which is 1. So I save that into current position because I will be manipulating this from position based on the position of the variable that I'm sorting. So initially I park it in current position and that value is going to be 1. Then I put a for loop starting from position, which is value 1, and I'll compare it against the previous elements, right? As I mentioned in the algorithm here, if I pick up the element 1, I compare it against 5, and then I compare it against 30, and if 1 is less than 5, I do a swap, and then I will compare, right? So I'll go in the reverse fashion all the way to the first element of the array. Therefore, here as well, I'm doing a decrement operation on the value of I. So the previous position is going to be I minus 1, which is 1 minus 1, 0. Therefore, since I started off with value 1, previous position is going to be value 100, and 90 and 100 are going to be compared. I also have a breaking check here because I want to make sure that I don't ever compare minus 1, index of minus 1, it will throw index out of one exception. Therefore, I have this check in place. So what will happen now is a previous position is 0, current position is 90, 90 is less than 100, a swap happens here between 90 and 100, and now 90's position is the position where 100 was there previously, which is nothing but the previous position, right? Therefore, I assign 90's position is equal to previous position because now the new position of 90 is nothing but the old position of 100, which is previous position. Now you understand why I have the current position assigned from the from position, because this is the original from position and this got manipulated here. Okay, there's a mutation. Now what we'll do next is I will compare 90 and 100. I have already compared it. Now I have swapped it. So this is the array that we see now. Okay, and after this, if you observe again, the for loop will execute, but this time previous position becomes 0 minus 1, which is minus 1 because I have decremented the value by 1, right, in the previous iteration. So it becomes 0. 0 is greater than or equal to 0. Therefore, it will come inside this for loop, but previous position becomes less than 0. Therefore, it will break out of it. And once it breaks out of it, all I do is current position is equal to current position plus 1 because now I have swapped 90 and 100. And the original current position I started off with 90, right, which is 1. Now I'll become 1 plus 1, 2. Now I have the elements that are sorted as 90 and 100, and I have to take up 70 next. Therefore, the current position plays a role here. Current position was initially 1, now current position becomes 2, and I just check if current position is the length of the array because I don't want to go beyond the length of the array. There is going to be a hard stop. I can't because it is going to throw an array index out of mode exception, just like it might throw for this one. Therefore, I do this check. I understand if it is not the length of the array. If it is going to be the length of the array, I just return the array because at this point the array is either sorted or not sorted, but I just return the array. I don't want to proceed with anything here. Otherwise, I call insertion sort again recursively with the new current position, which is going to be the position of 70 or value 2, and I'll pass the array. Note that I'm passing the same array around because this array manipulation is in place. This is also an in-place sorting algorithm. Therefore, the positions are just going to be swapped in the array, and the array is going to remain the same. Therefore, I pass the same array, and now updated current position 2. So this is the array that will go in the second iteration with value 70. Now 70 will be compared against 100 and there will be a swap. So once I swap it, again it will become 90, 70, 100, 60 and 30. Now again 70 will be compared against 90. So in order to compare 70 with 90, I need to know the new position of 70, right? Because 70 was initially pointing to position 2. Now 70 is in position 1 of the array. Therefore, that is the reason why I have this assignment of from position is equal to previous position. Now 70 is nothing but the position of earlier position of 100. Okay. Now it's in the position 1. Now it will compare 70 with 90 because previous position is becoming 0. It will compare 70 and 90. It will do a swap again, and again we'll reach a point where previous position is less than 0. We'll break out of it, and by that time we'll have the array as 70, 90, 100, 60 and 30. So this is the current position value 2's result. Now current position becomes again 3 because again I do the increment operation. Likewise, I'll check again. I'll call insertion sort with this particular array, which is 70, 90, 100, 60 and 30. It will pick up 60. It will compare against all of them. It will keep swapping one by one, and finally same thing will happen with 30. And at the end of that, I'll reach the position current position is equal to array.length. That means I have sorted the complete array, or if it was already sorted in the first place, then I just return the array. Right, now let's execute this code and let's see what is the outcome. And you can see 30, 60, 70, 90 and 100. Observe very carefully that in this implementation I'm using a for loop combined with the recursion call. Okay, when you have this kind of an implementation to calculate the time complexity, right, the time complexity for insertion sort is also O of n square. Why? Because you pick up an element on the unsorted side, you compare it against all the elements on the sorted side, right? In this worst case scenario where every element is in the descending sorted order, you do a swap for every comparison, right? You pick up 90, you do a swap. You pick up 70, you do 2 swaps. You pick up 60, you do 3 swaps. Therefore, this is the worst case arrangement that you can give to this insertion sort function, and it will do a swap for every comparison. Okay. So if that is the case, for n elements, you will do n swaps, and therefore the time complexity of this algorithm is O of n square, because it runs for n positions. If the value of the array, descending array is size n, very large, this for loop will run n times, and after running n times, insertion sort may also be called n times, roughly. So it's nothing but n into n, O of n square complexity. And with this we come to the conclusion of this video, and this is just a print function I wrote to print out the elements of the array. That is what you were able to see when I executed this code here. And if you like this video, do hit the like button, subscribe to CodeWithAni if you haven't already, and I'll see you guys in the next video. If you have any doubts regarding this video, please do watch it again, pause it, understand the logic, pause where you want, and you can take a snapshot of the code and try to implement it yourself in different ways. This can be done in multiple ways. I've just used the combination of for loop and recursion. You can also do it using 2 for loops. You can do it with a while loop, whichever suits your convenience. I urge you to try it out by yourself and let me know in the comment section how it went through. So I'll see you guys in the next one with another sorting algorithm. Until then, bye bye. Take care, guys.